So I'm going to try to give a little explanation of where degrees of freedom come into play. So we've got three graphs here. They all look sort of normalish. The blue one is we'll call the standard normal distribution of that z-table. So we've found some, and it's a sampling distribution, so we've taken some population, taken all possible samples of size n, and found the sample mean of those samples, and then graphed all possible sample means, and it's normally distributed. And using math that is beyond the scope of this class, the magic number happens to be 30. So anytime we're taking samples of 30 or more, and we graph the probability of sample means, it's going to look like a normal, so like the blue one. So when we're talking about probabilities, let's say these lines are negative 1.96 and 1.96 standard deviations away from the mean. Let's say, let's put a line. So here's the mean of all the distributions. So we're 1.96 standard deviations away, and between these 2 points in the blue graph, 95% of the data are within there. So this is where we get our 95% for our confidence intervals, 2.5% out here, 2.5% out here, and that's what the normal looks like. The red graph has, let's say, 25 degrees of freedom, so smaller sample size, and the graph kind of looks normal, but it's a little more, it's squished down, it's spread out a little bit. So it's, as you can see, it's lower than the blue one, then it's outside of the blue one. So for this graph, so we've done the same thing. We've taken samples of size 26, not quite, found the sample means and graphed the sample means, the probabilities, and it looks pretty normal, but not quite. So for this graph, so looking at probabilities for this graph, 95% of the data, to get 95% of the data, we have to go out to 2.060, negative 2.060. So for the red graph, between these 2 points is 95% of the graph, just because of the shape of it. So the critical values change. Now let's say for the yellow graph, that's, I don't know, let's call that 15 degrees of freedom. So we've taken samples of 16, size 16, on the sample means, blah, 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 blah. Samples of size 16, n is 16, degrees of freedom is 16 minus 1, or 15. So for the yellow graph, again, it's same mean, it looks kind of normalish, but it's, squished down a little more, spread out a little more. So in order to get 95% of the data between two critical points, or two critical values will be plus or minus 2.131. So that's where the degrees of freedom come into play when determining critical values. This is graphically, technically, what's going on.